What's up, everybody? Mr. Cozad back with another video lesson. And before we start, I gotta tell you, today's a great day to be alive. I'm so happy that you found us. I hope that this video is helpful to you. I hope that this video is a good use of your time. You're either watching this because you have to learn about graphing logarithms or you want to learn about graphing logarithms. So whether you're my current student, former student, or somebody that doesn't even know who I am, I'm happy that you're here. And like I said, I really hope that this is helpful. If you find this video to be helpful, check out the other videos on the channel, see if there's anything else that can make math a little bit easier for you. So today's topic is graphing logarithms. Okay, so if you'd like to know what a logarithm is, you can go back and find another video that I did where on evaluating logs, where I talk about kind of what a log is, how to evaluate it, how to write log equations. That would be a good place to start. But the purpose of this lesson is to specifically look at graphing techniques. Okay, so let's get started. So here are some basics that you need to know about graphing logarithmic functions. Probably the most important thing to remember is that exponential and logs are inverses. So exponential and logs are inverses of each other. And, running out of room. Inverses, where can I put that? Let's put it down here. Are inverses. Okay, and if you're my student and you watched the last video, the kind of introduction to logs, we talked about this a little bit, that when we take inverses, we switch x and y, okay? So x and y both switch, and we reflect across the line y equals x, okay? So graphically, what that's going to change on our graphs of logarithmic functions is we still have an asymptote, but here the asymptote will be a vertical asymptote instead of horizontal like it was in the exponential functions. So when we write the equation, look down here at the bottom, when we write the equation of our asymptote, we're actually going to use the h value instead of the k value, okay? The h value instead of the k value. Now again, if you're my student, that'll make some sense to you. You know what I'm talking about when I talk about h. If you're not my student, see how we do a couple of these examples and you'll pick up on it very quickly, okay? The other thing that changes is that the range is now going to be all real numbers, okay? Remember that when we switch x and y, for the exponential graphs, the domain was all real numbers, but because we switch x and y, the range now becomes all real numbers, okay? Some other things to kind of point out to you or to notice is that the general shape of these graphs are kind of the same. They're always going to go away from the asymptote. Sometimes they're going to go up to the right. Other times they're going to go down to the right. Okay, and there's rules that I'll let you look at and write down on the bases, which tell you which direction you're dealing with. Okay, so the best way to do this, my philosophy, is to just get in and practice. So let's get it. So problem number 1, okay? I'll let you pause the video here and write this down if you're taking notes. But I'm not going to pause and take time for you myself. So if you need to, pause it, write this down. Grab some graph paper if you have some. If not, you can just draw a sketch of a graph on the paper that you're taking notes on. Okay, so graph the following function, state the domain, we're going to have to do that, the range, and the asymptote. Okay, so where I like to start is I like to start with the asymptote. Okay, so the asymptote we know is going to be vertical. So vertical lines are always x equals. And like I told you on the last slide, it's always going to be x equals h, okay? So the h value on this equation is -1, okay? -1. Remember that for the h values, we always take the opposite sign. So since it appears as +1 in the function, when we pull that h value out, it comes out as a -1. So let's start by drawing my vertical asymptote at x equals -1. Now, the next step, look down here at the bottom of this page, I give you a hint on what to do next, okay? The next step is to change it to exponential and then make a table. Pick y values first. So let's do this first. Let's change it to an exponential. So we're going to take this equation and we're going to rewrite it as exponential. So we start with base 3, okay? And it's going to be base 3 to the y power equals x plus 1, as I rewrite that as a exponential function. Again, if you have no idea how I did that, the process that we use there, go find my other video on evaluating logs, and I go through the process of how you can convert a log to an exponential. Okay, so there we did. We changed it to exponential, and then it says, let's make a table. So we're going to make a table of x values and y values. But here's the catch. Most every other time you've ever made a table of values, you always pick the x values first. But that's not going to be very helpful for us here, because if we plug in x values, we've got to be able to solve for the exponent, and that's not always going to be easy to do. So my advice on problems like this is to actually start by picking the y values. So, for example, if I plug a 0 in for y, 3 to the 0 power is 1, and then if I subtract this 1 to the other side, I get that x equals 0 as well. So 0, 0 is a point on this function. Okay, now let's go ahead and let's pick another y value. Let's go ahead and keep it kind of simple. Let's do y equals 1. So again, when I plug a 1 in for y, 3 to the first power is simply 3. Subtract 1, we get 2. So when y is 1, x is 2. So let's graph that point. Go over 1, 2, go up 1. Okay, let's go ahead and get a couple more points. So let's see what happens when y is positive 2. Okay, y is positive 2. So again, plug a 2 in for y. 3 squared is 9. 9 minus 1 is 7. So when x equals 7, 1, 2, 3, 4, 5, 6, 7, it's not 7. You guys know that. My goodness, that was bad. Okay, 3 squared is 9. 9 minus 1 is 8. Okay, you guys probably thought I was completely psycho for thinking that that was 7. So thanks for being patient with me. So 8, go all the way over to 1, 2, 3, 4, 5, 6, 7, 8, up 2, and drop a point off right there. Okay, now that is enough to be able to draw a sketch of this curve. And remember, when you draw it, we approach the asymptote, but we actually never touch. There's always going to be some space in between the curve and our asymptote. Okay, so the only thing that we haven't done yet is talked about the domain and the range. Okay, so where can we put that? Let's do it right here. The domain of this function, again, we always go for domain. We always go from left bound to right bound. Okay, so the left bound here is the asymptote. It's x equals -1. So that's going to be my left bound, -1. And then my right bound is going to go all the way over to infinity. So the domain is from -1 to infinity. And remember, when we use interval notation, we use parentheses for both, because you can never actually reach infinity, and the asymptote means that you're never going to actually touch -1. Now, the range on log functions will always be easy, because it will always be all real numbers from -infinity to positive infinity. So that should be pretty straightforward for us. Okay, let's try another problem. Okay, so here's the second one that we're going to do. So again, I would encourage you to pause it here to give yourself a chance to write this function down, at least write this part down, and draw yourself a graph if you don't have graph paper, and we'll jump right in. Okay, so step 1, I'm going to identify the asymptote. So I want to look for the h value. Now, this problem is unique because we've got to really decide, is this -3, is that the h value, or is it the k value? Remember, the general form of this equation is going to be y equals a log base 2 of x minus h plus k. The h will always be in a set of parentheses like this. So since you don't see parentheses, this -3 is the k value. So because the h value, we don't see one, we know that h is 0, so we would say that the asymptote is vertical, always for log functions, so it's always x equals h, but here the h value is 0. So let's graph the line x equals 0. Just draw it right on top of your y-axis. Okay, so now the next thing we're going to do is we're going to convert this to an exponential equation. Okay, so we want to get the log base 2 of x all by itself. So the first thing that I'm going to do is I'm going to take this -3 and I'm going to move it to the other side. We do that by addition. So that turns into y plus 3 equals -2 times log base 2 of x. Now the next thing I'm going to do is I'm going to take this -2 and I'm going to move it to the other side. Now the way we algebraically do that is through division. So this becomes y plus 3 divided by -2 equals log base 2 of x. So now that we've gotten the log isolated, the log is all by itself, now we're able to write this as an exponential. Okay, so base is 2 because the base always matches the base of the log. The exponent will be y plus 3 all over -2, and that equals x. So now what we're going to do is we're going to make a table of values where, remember, we're going to pick the y values first. Pick the y values first. Now, the y value that I pick first is I usually pick the y value that makes the exponent equal to 0. So in this case, I'm going to select y equals -3. Because when I plug -3 in for y, I get -3 plus 3 is 0. 0 divided by -2 is 0. So 2 to the 0 power is 1. So x would equal 1 when y is -3. So let's go over 1, and let's go down 1, 2, 3, and plot my point. Okay, let's pick another y value. Now, this is where you kind of have to think a little bit because you want to be strategic about these y values that you pick. I want to pick a y value so that when I plug it in here, I get a relatively easy exponent, okay? So think for just a minute about what is another y value that you could use that would make this kind of convenient to find a power of 2. So I'm going to start with -5 is a strategic y value because -5 plus 3 is -2. So then -2 divided by -2 would be +1. So 2 to the first power would just be 2. So that's my x value when y is -5. So go over to 1, 2, and go down 1, 2, 3, 4, 5, and drop off another point. Okay, we could pick another value. So let's keep with the trend and go with -7. So -7, when I plug that in, -7 plus 3 is -4. -4 divided by -2 would be +2. So 2 to the second power would be 4. So when y is -7, x is 4. So let's plot that point. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And we can start to see on the graph that I've drawn, I've kind of run out of room, but that's probably enough to be able to draw a sketch of this curve. So we are bending away from the asymptote, like so. Now, once you see the graph, writing the domain and range should be pretty easy for us, okay? The domain, remember domain is always left bound to right bound. So the left bound here is the asymptote, which is 0, and the right bound is +infinity. Now for the range, every single one of you should be able to get the range right every single time because it's always, for log functions, going to be -infinity to +infinity. So again, the steps here. Step 1, identify the h value to find the vertical asymptote. Step 2, isolate the log and rewrite that log function as an exponential function. Step 3, make your table of values. Step 4, graph it and find your domain and range. So let's do one more problem together. Okay, what I would encourage you to try on this third one is pause the video now and try doing this by yourself. Try going through it alone with what I've kind of talked you through already. And then when you're done or you're ready or you get stuck, you can turn the video back on and check your progress. So welcome back. Hopefully you actually did what I asked you to do and pause the video and tried this, okay, so that I can give you kind of some real-time feedback on the work that you just did, okay? So first step I always like to do is identify the asymptote, okay? So it's always vertical for log, so I start with x equals, and I look at my h value here, which was a 2. Again, check that. Make sure it's x equals +2. Remember, on the h values, you don't trust the sign. You always take the opposite sign. So if it shows -2, that h value is actually +2. So let's draw that asymptote in. So x equals 2. Okay, next step, rewrite it as a exponential. So first thing I'm going to do is I'm going to take this 2 and move it to the other side. using subtraction. So I've got y minus 2 equals log base 0.5 of x minus 2. And there it is. It's isolated, the log is. So now I can just simply rewrite it. Now, I'm actually, instead of using 0.5, I'm going to use 1/2 because I'm going to do some of these calculations without a calculator, and dealing with 1/2 is easier to me than 0.5. Okay, so I'm going to rewrite the base as 1/2. Okay, and the exponent is y minus 2, and that equals x minus 2. So now that you've rewritten it as an exponential, now what we're going to do is we're going to select some x values, some y values, and figure out the corresponding x values. So what I do first is I pick the y value that makes the exponent equal to 0. So that'd be y is 2. So when I plug a 2 in for y, 2 minus 2 is 0. 1/2 to the 0 is 1. And then I add this 3 to the other side, I get x equals 3. So when y equals 2, x equals 3. 1, 2, 3, 1, 2. Plot those points. Okay? Okay, so let's pick another y value. So the next one that looks like it would be nice to do is y equals 3. Okay? When y equals 3, I plug a 3 in for y. 3 minus 2 is 1. 1/2 to the first power is... oh, excuse me. That's embarrassing. Hopefully you said bless you. I appreciate that in the digital space, wherever you were. Thanks for looking out for me. So don't get me distracted. So 3 minus 2 is 1. 1/2 to the first power is just 1/2. So 1/2 plus 2, I think about that as 4/2. So 1/2 plus 4/2 ends up being, wrong tool, 5/2. Okay, 5/2. So I've got 2/2, 4/2, 5/2 is 2.5. And then I go up 1, 2, 3, and plot a point. Okay? Okay, so let's try another x value now, or y value. So we're going to go a little crazy here, and we're going to pick y equals 1. Okay? Now, when I plug a 1 in for y, 1 minus 2 is negative 1. Now, 1/2 to the negative 1 power, I'm going to give you a little bonus work over here. 1/2 to the negative 1 power becomes 2 to the first. We just take the reciprocal, and the exponent becomes positive. So 1/2 to the negative 1 power is 2, and then if I add this 2 to the other side, I get x equals 4. Oh, that's going to drive me crazy. I like the symmetry. Some of you OCD people want that 4 to be the same color as well. Okay, so when y is 1, x equaled 4. So I go over to 1, 2, 3, 4, and go up to 1. Okay, so I'm starting to kind of get a good idea of what the graph's going to look like up here, but I kind of want to see what's happening down here. So let's maybe pick one more y value. Let's pick when y is negative 1. Let's just try that, when y is negative 1. Okay, so when I plug a negative 1 in for y, I've got negative 1 minus 1 is negative 3. Okay, so now what I'm going to be doing is I'm taking 1/2 to the negative 3rd power. Okay, 1/2 to the negative 3rd power turns into 2 to the 3rd power because we take the reciprocal and then the exponent becomes positive. So when I take 2 to the 3rd power, that gives me 8. 8 plus 2 more gives me 10. Okay, so when x is 10, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I ran out of room. So just keep going a little bit. 9, 10. Y would be down here at negative 1. So that gives me a pretty good idea of what the shape of this graph is going to look like. Okay, and that I feel pretty comfortable about the graph that I can draw. Okay, so the only thing that we have not done yet are the domain and the range. So let's knock those out. The domain, remember, is always left bound to right bound. The left bound here is always going to match the asymptote. So that asymptote in this problem is 2. Right bound is infinity. And the range, every single person should be able to get the range right on every single log function because it's always going to be negative infinity to positive infinity. Always and forever. Y'all, that's everything I know about graphing log functions. Again, just to summarize the steps, find the asymptote. It's always going to be vertical. rewrite the log function as an exponential function, and then make your table of values. But the trick is pick the y values first and find the matching x values. Man, I hope that was helpful for you. Thanks for spending some time with me, and I'll see you next time.